Okay, a piecewise defined function is a function that has more than one definition dependent on the input. Okay, I just noticed this looks sort of like the profile of a face maybe. Sorry. But here's an example of a piecewise defined function. This function has three different outputs, 1, x minus 3, and negative 4. And these outputs take place on these given inputs. So the output is only 1 if x, the input, is less than negative 3, and so on. So an easy way to see how to do this is to think about f of x equaling each of these functions individually and graph them each as individual functions. So let's take a look at the function y equals 1. Y equals 1 is a horizontal line where y is 1. So it looks something like this. Okay, so that is the first function. We'll worry about the domain stuff in a little bit. So let's look at y equals x minus 3, and I'm going to write it as 1x minus 3. And I'll point out that 1 is the slope, so you'd write it as 1 over 1 to have a rise and a run. And negative 3 is the y-intercept. So this is the slope. And now if you want to graph this function, the y-intercept is at negative 3. And you rise 1 and run 1. And you can continue to do that, and you end up with this line. Looks something like that. And finally, y equals negative 4 is again a horizontal line at negative 4, so it looks something like this. Now, the first function only takes place, y equals 1, when x is less than negative 3. So negative 3 on the x-axis is here, so I have to go up, put an open circle here, and so this is the part of the function we're interested in our piecewise defined function. The second function takes place when x is between negative 3 and 2. So negative 3 and 2 is right there. Negative 3 is included, so I'll put a closed circle there. 2 is not, so I'll put an open circle there. And we're only interested in this part of the function here. Now if you're curious, how do you figure out exactly where this point is down here? Well, x is negative 3. If you plug negative 3 into this middle function, you have negative 3 minus 3, which is negative 6. So over here, this would be a y value of negative 6. And up here, you can do the same thing. If x is 2, 2 minus 3 is negative 1. So this y value is at negative 1, and that is what it appears to be. Okay? Finally, y is negative 4 if x is greater than 3. So 1, 2, 3, open circle, everything to the right here. Okay? Now we piece together the purple parts, and that's our piecewise defined function. So we'll graph the piecewise defined function f of x here. I sort of moved things around so we'd have a little more room. Okay, so we have this first purple function from negative 3 to the left. Looks like this. So that's this one here. Then we have the middle function from negative 3 to 2, and it goes down to negative 6. So at negative 3, it's at negative 6. 1, 2, 3, 4, 5, 6, open circle. And then at positive 2, it's at negative 1. We're down here, closed circle. And then we need to connect those with a straight line. Looks like that. And finally, the last picture here, when x is positive 3, y is negative 4. Open circle, and to the right forever. So this is the graph of the piecewise defined function defined here, and we just simply looked at the different pieces and put them together on their restricted domains.